Hello everyone. In this video, let's talk about how we add or subtract rational numbers. That is, how we add or subtract fractions. So on the screen, I have the rule written out. If a over b and c over d are rational numbers, then a over b plus c over b is equal to a plus c, all divided by b. And the same thing for subtraction. So the one thing to note here, in these fractions, I do have the same denominator. So all of my fractions are over b, and that's really important. So to add or subtract fractions, we need to have a common denominator. Now the first thing I want to do is I want to talk about why we need that. So why do we need a common denominator to add or subtract? One way we could think about this is that I need my fractions to be expressed in the same size. So let's do a visual here. So let's say I just have a couple rectangles, and these rectangles I'm going to have represent a couple fractions. So for the first one, let's say this represents 1/2, and then my second one will have this represent 1/3. So if I split this first rectangle into two pieces, if I shade in one of those, here's a visual representation of 1/2. Now for this one, let's cut this into thirds. So I'll go the long way, and then I'll shade in just one of these. Now this represents 1/3. So if I wanted to add these two fractions together, right now I couldn't do that because they are different sizes. So if we look at the shaded regions, because they're different sizes, they don't combine together nicely. Instead, what we could do is I could make them all into regions that are the same size. So let's take our first rectangle, and we will also split this into thirds. And if I take a look at what I have shaded here, I have 3 regions that are shaded. So 3 out of the now total 6, that's the same representation as the 1/2. In my second rectangle, we'll split this in half, and here we can see now I have 2 regions shaded. But the reason this is nice now is because all of these regions, so we have 1 right here, here's 2, 3, 4, and 5. All 5 of those little shaded regions, those rectangles, they're all the same size. And because they're all the same size, this makes it really easy to add them together. I can just count. In total, we have 5, and now their size, we split them up, so now they are 6. So there's our result. And this idea, this is something we do all the time, especially when talking about money. For example, if I take a look at, let's say I have 1 dime, and I have 1 quarter. Now, we already know how much money this is in total, but in our head, what we do is we convert these into something that's the same size. So the way it stands right now, dimes and quarters we can't combine together. But because I know a dime is the same as 10 cents, and I know a quarter is the same as 25 cents, I'm changing the size of their denomination here. So instead of saying this is 1 dime, I'm saying it's 10 pennies, or I'm saying it's 10 out of 100, right? 10 cents out of $1. And altogether, now we can add this and we can say that, yes, this is 35 cents. So that's the reason why we need a common denominator to add or subtract. We need the sizes of the denominators to match. So let's do an example. Let's do one that doesn't have a common denominator. So let's add 3 over 4, and we'll add this to 1 over 6. So right now the denominators, they don't match. And if I want to add these, I do need that common denominator. So the first thing we need to do is we need to use equivalent fractions to get our denominators to match. So if I look at 4 and 6, I'm looking for a common multiple. So multiples are when you multiply a number by 1, 2, 3, what we end up with. So for 4 and 6, the common multiple, the smallest one at least, is going to be 12. So 12 can be divided by 4, and it can also be divided by 6. So to get these to match up, I want my denominator to be 12 for my first fraction. So we need to multiply the top and bottom by 3. So we'll do 3 times 3 up top, and we'll do 4 times 3 in the denominator. This will give me the denominator 12 that we're looking for. And in the second fraction, if I want this to be 12, we need to multiply top and bottom by 2. So we'll do 1 times 2 in the numerator and 6 times 2 in the denominator. So we're creating equivalent fractions. This first one, we end up with 9 over 12. So 9 over 12 and 3 over 4, those have the same value. We're just changing the size now. And then our second fraction, we have 2 over 12. And now that they have the same denominator, now that they're expressed in the same size, we can add them together. So 9 plus 2, we get 11 over 12. And here's our final answer. As always, you would want to double check that to make sure if you can simplify further, you would want to do that. But otherwise, the same exact rules apply when you're subtracting fractions as well.